need to access request metadata, manage state between middleware, or interact with the MCP session, all without breaking your existing function signatures. You'll see how FastMCP Context object gives your tools and resources direct access to the server's capabilities, from logging and progress reporting to secure state management. The pattern is simple. Just add a CTX, context, parameter, and FastMCP handles the rest. From FastMCP, import FastMCP Context. MCP equals FastMCP. Name equals context demo. At MCP resource / user data. Async def get user data, CTX, context, dict. Fetch personalized user data based on the request context. Hash context is available as the CTX parameter. Return userid. Example. At MCP, resource / users / user ID / profile. Async def get user profile, user ID, SDR CTX, context, dict. Fetch user profile with context-aware logging. Hash context is available as the CTX parameter. Return id, userid. This demonstrates the dependency injection pattern combined with contextual resource management in FastMCP. The code shows how to create server-side resources that automatically receive a context object, which provides access to request-specific capabilities like logging, progress reporting, and client interaction. The distinctive aspect here is that context is injected implicitly through type hints, keeping your function signatures clean while enabling rich runtime capabilities. The pattern works by decoupling resource implementation from infrastructure concerns. FastMCP's runtime detects the context, type hint, and injects a request-scoped context object, giving your functions access to the current execution environment without explicit initialization. This creates a clean separation where your business logic focuses on data processing, while cross-cutting concerns like logging or client communication are handled through the context interface. This approach solves the problem of boilerplate infrastructure code in RPC services. Instead of manually passing request objects or initializing logging systems, you declare dependencies through type hints and let the framework handle the wiring. It's particularly valuable for AI integrations, where tools need to interact with clients dynamically, or in microservices where you want to keep resource implementations focused on their core functionality, while still having access to the full server context when needed. Let's break it down line by line. From FastMCP, import FastMCP Context. This imports FastMCP, the core class for creating AI callable tools, and Context, which provides request-specific metadata and logging capabilities. These are the foundational components for building FastMCP resources that integrate with AI systems. MCP equals FastMCP. Name equals context demo. This initializes the FastMCP instance, the central orchestrator for all AI callable tools. The name parameter identifies this service in logs and error reports, enabling traceability across distributed systems. At MCP resource / user data. Async def get user data, CTX, context, dict. Fetch personalized user data based on the request context. This registers an AI callable resource at the resource / user data endpoint. The CTX, context, parameter follows FastMCP's standard pattern for request metadata, logging, and progress reporting, while the async definition enables non-blocking execution. Hash context is available as the CTX parameter. Return userid. Example. This returns a hard-coded user data response, demonstrating the basic FastMCP resource pattern. The CTX parameter is available for context-aware operations like logging or progress reporting, though unused in this minimal example. At MCP, resource//users/user ID/profile. Async def get user profile, user ID, SDR/CTX context, dict. Fetch user profile with context-aware logging. This defines a parameterized resource endpoint using FastMCP's routing system. The userid path parameter extracts values from URLs like resource//user/123/profile, while CTX context provides standardized logging and request tracking across all FastMCP tools. Hash context is available as the CTX parameter. Return id, userid. This returns a simple user profile dictionary with the requested userid. The CTX parameter remains available for context-aware operations like logging or progress reporting, though unused in this minimal example. All FastMCP resource handlers should accept this context parameter for consistency. Resource templates and context integration. The FastMCP 2 pattern shown here combines dynamic URI templates with request-scoped context, enabling personalized responses without hard-coded paths or shared state. Context objects are ephemeral. Each request gets a fresh instance, so never assume data persists between calls. This approach scales from simple endpoints to complex systems while maintaining clean separation between requests.
The URI that never changes handles every change.